So I like to usually start my talks by asking, who here has heard of Stack Overflow? Absolutely, that's what's so great about Stack Overflow is that you ask a question, you get an answer, you search on Google, and you get an answer to your programming question. It really is a part of our workflow in working in R. And R has been a really big part of Stack Overflow. There have been 190,000 questions and answers about R in the history of the site. It really is useful because usually when you're about to visit Stack Overflow, maybe you have a programming problem and it's kind of frustrating, but then you visit it and you get your answer. And that means that every time you're programming, you're visiting Stack Overflow and you're giving us this really amazing data about what you're using and what you're programming. And as a data scientist at Stack Overflow, I've been using that data to learn a lot about the history of the R language. From that, we can use that based on data on what do our users ask, what do they answer, and what do they visit, what do they view, even if they're not interacting with the site in another way. So from that, I'm going to show the kinds of things we can learn about the R community. One question is, how has R grown? Well, the site was founded in 2008. And back then, there was almost no R questions. In fact, the first question about R on Stack Overflow happened more than a month into the site of how to access the last value in a vector. For the first year, R wasn't a big part of the site, but it grew a lot in summer 2009 with a flash mob for the R community at the O'Reilly conference OzCon. So there, it was actually one day where a number of people at the conference asked and answered each other's questions. That was actually encouraged by one of the founders of the site, Jeff Atwood, and it really led to an enormous growth in the number of questions being asked about R since then. And we can see from other tags, we can try comparing it to other languages and technologies. So for example, we can compare the R tag, which has been growing a lot, to Python, which has really always been a lot larger because it's much more than a data science language. And that has also been growing very rapidly in the last couple of years. We can compare it to MATLAB, which it used to be a similar size, but MATLAB's growth has kind of stalled in terms of questions asked in Stack Overflow, while R has grown. We can also compare it to the language Julia, which has a much smaller number of questions asked, which means both that it has fewer users, and I think mostly that the conversations around Julia haven't moved on to Stack Overflow yet. They're happening in email lists or other resources. There's so much we can learn by comparing number of questions asked in each of these tags. For example, we can look at some of these popular data science packages in both R and Python. ggplot2 has been growing rapidly, but really rapid growth has been some Python packages like NumPy, steady growth over the last 9 years, and Pandas, which has shown very rapid growth since 2012. All this kind of shows a world where data science is becoming increasingly relevant in programming. We could also compare outside of Python and R some big data technologies, and we can really see that Cassandra stayed a little bit smaller. Hadoop has been steadily grown but kind of leveled off, but nothing compares to the rapid growth of Apache Spark starting from its introduction in 2014, and then more recently TensorFlow. Google's TensorFlow for deep learning is one of the fastest growing tags on Stack Overflow. It showed an enormous amount of adoption in a short time. And really, you can play around with this and find out about a lot of other languages outside of R in the data science world, such as the comparison between Ruby on Rails or Flash, some things that have been shrinking while the data science ecosystem was growing. And you can play with all of these yourself on our Stack Overflow Trends tool. So you can find that at insights.stackoverflow.com/trends. It's an interactive application that you can put in any Stack Overflow tag, and it'll show its history on the site since 2008. So there's a lot you can learn from different tags, but let's zoom in on the R ecosystem and see what we can learn about packages. To do this, I'm going to be using entirely open data. This is a data set that we have up on Kaggle called R questions from Stack Overflow. This is every single R question up until that point, including its full text and some metadata about it. And you can go in and parse it. And in particular, we can find uses of library and require in the R code to these questions and answers. So here, for example, we can see someone that used Plotly and ggplot2. We could find another question where someone required micro-benchmark and data.table, and from that we can count the discussions and the questions and answers around each of these packages. The most commonly appearing R packages across Stack Overflow questions and answers, really the standout ones are ggplot2, dplyr, and data.table. So those are three real staples of data manipulation and visualization. After that, we can see plyr, shiny, reshape2. You can note that out of the top 12, all 8 of them have the same author, Hadley Wickham. And yeah, we can see here some of the things that are most influential, or at least that people ask the most questions about. We can also see how that's been changing over time. ggplot2 has been asked about quite frequently as a fraction of R questions since roughly the start of the site, maybe declining a little bit. dplyr and data.table have both been growing over the course of the site. And notice that dplyr sort of replaced plyr, the previous iteration of Hadley Wickham's packages. We could see other things that grew were shiny, DevTools. We can see some things like reshape2 that became popular but has since been replaced by tidyr. And we can see some of the ways that the R landscape has changed in the last 9 years. But we're sort of making these connections ourselves. So one thing I really like to do with these packages is find what does the landscape of R packages actually look like. And to do that, we take what pairs of packages are often asked about and answers to the same questions. And by finding those piercing correlations between those, we can find connections between R packages that are often used to solve the same problems. And that gives us this picture of the R package ecosystem. So if we start over there on the left, we've got interactive visualization, shiny at the center with DT, ggviz, shiny dashboard branching off of it. Through the connection of leaflet, we have a collection of packages about maps, ggmaps, SP, maps, map tools. That connects to a general visualization cluster. We can see ggplot2 as one of the major anchors, also grid, grid extra, scales. We see the lattice package branching off of it. And that connects to our largest cluster, which is data wrangling. dplyr and data.table being the two largest indicators. We also have tidyr, split stack shape, per, tidyverse, magrittr, things that are involved in general data wrangling. Branching off of per, you can see my own package, Broom, and NLME and LME4, generally representing models. We have a set of things about web, processing web and API, such as XML and HTTR. And then we have a few branches that are somewhat separate. We have R Markdown and knitr in a reproducibility cluster for answering questions about those types of topics. We have one about C++ and performance, like RCPP and micro-benchmark, about strings like string I and string R. We see random forest and caret being linked, but also being linked to some work on parallelization. Time series, and spreadsheets with connection of Excel Connect and Excel SX. So this really gives us a sense of the constellations that make up the galaxy of R. You might notice that some of these pairs of packages are used together, and others are really more competing with each other. Some will work together to solve a problem, others are two different solutions to the same problem. One way that you can separate those is look at, did they tend to be used in the same answer, or do they tend to be used in different answers to the same question? So when they use together, it would be in an answer, for example, where you see ggplot2 and scales used together, or used in competing, such as these two answers to the same question, tidyr and dplyr, versus a different answer that uses reshape. So what I did is took the correlation of appearing on the same answer, subtracted the correlation of appearing on different answers, and you can get a measure of how much they're complementary versus competing. And these were the pairs of packages that tended to be competing. By far, we see data.table and dplyr offering two different solutions to many of the same problems. We also have tidyr, things that replaced each other. Tidyr generally replaced reshape2. We can see, yes, stringi and stringr serve very similar purposes. Split stack shape and tidyr are competitors. Cow plot and grid, two different ways of making visualizations. And we can see XML2 and XML, we see some things where people are working in the same space. So I answered some questions we can learn about from Stack Overflow questions and answers, but another question is, where do people use R? Where is it used around the world? And we have some really terrific data for that. Unlike the rest of this presentation, this part is on Stack Overflow traffic, so it's not an open data, it's just on things we have at the company. We can see is what countries used R the most relative to other Stack Overflow traffic, so as a percentage of their total Stack Overflow visits. Out of the top the 16 countries with the most traffic, the United States used the most R, closely followed by the Netherlands. I think we have some representation of a lot of these countries in this room, from Australia, from the United Kingdom, from Germany. Some of the countries that used much less R included Vietnam, Ukraine, Russia, and India. That's often, if you look at the traffic from those countries, there's a lot more PHP development, there's a ton of Android mobile development, and there's relatively less data science. So if you looked across the entire world, here the red represents the largest fraction of programmers in terms of Stack Overflow visitors being R users as opposed to other languages. Oops. And what you can really see from that connection is that there's a relationship there where generally the richer a country is, the more it uses R. I think it's mostly a confounding factor of, say, the percentage of a country that has PhDs, but we can see, yeah, that covers most of the predictions we'd expect. Areas like Switzerland, United States, and Norway using lots of R, and countries like Pakistan and Vietnam using relatively little as opposed to other programming technologies. In fact, R happens to be, plot, ggplot2, and R happen to be the tags with the highest correlation between a country's GDP and their traffic to it, with some of the things that were anti-correlated with GDP, including Android and some PHP technologies. So that gives us a sense of what kind of countries tend to be overrepresented in terms of their traffic to R. We can also look within the United States, where I'm from, and we can see that there are a few states that use a lot more R. It's very hard to see here, but Washington, D.C. uses the most R in the country. You also have some states in the Midwest and Massachusetts that use a lot of R. Why is that? Well, to answer that question, we might want to break it down by industry, because what's really happening there is schools. So by taking the IP address of our visitors and matching them back to companies, we're able to match up what industry they come from. And we notice that by the most traffic to R this is only in the United States because that's all we're able to apply this method to, but my understanding is it's similar in other countries. The most traffic comes from academics, from universities, researchers, and from healthcare. Much less occurs in tech, like companies like Google and Facebook, or in the electronics and manufacturing space. I find that it's interesting, but I'm also really interested in that R has been growing so rapidly. In what industries has been growing fastest? So I tried looking at the year-over-year change from 2015 to 2016 within each of these industries. And by a large margin, the fastest growth has come in the consulting industry as well as in government. Further examination has generally shown this is absolutely true. I think both consulting and government have shown a lot of growth in the data science space in general, as well as R in particular. We look a lot more at universities this is a graph of some within each country, some universities that asked a lot of it are like Yale within the United States, or University of Warwick within the United Kingdom, UBC in Canada. And you can find out a lot more about that on our Stack Overflow blog post, How Do Students Use Stack Overflow? Stack Overflow blog has a lot of other interesting insights that you can browse through and find out about, with analyses of our data that are very similar to this. So if you found this stuff interesting and you want to analyze the data yourself, we make some great open data resources available. So I already mentioned we have a Kaggle data set with every R question ever asked, every Python question ever asked, as well as one with 10% of all questions that you can do some interesting text mining on. We have the Stack Exchange Data Explorer that lets you run SQL queries on our actual database, or an anonymized version thereof. So if you want to just do some group by summarizing, download some aggregated data, this is a really good resource. We also have the Stack Exchange API, which is useful if you want to get real-time data. For example, if you want the last 100 questions in the R tag and you want to do some machine learning on them. And that has the StackR package, which I wrote, which has an API, an R client for that API. We have and if you want to download absolutely everything that has ever been into the Stack Exchange data, you've got the Stack Exchange data dump with a few very large XML files with all of our data. So there's so much that you can do with understanding how people learn and ask and answer, and how the technology ecosystem has been changing. And finally, if you're not interested in analyzing the data yourself, you want us to do it for you, we have a consulting product called Stack Overflow Insights, where we can pull together our data, including all of our traffic and data that's not publicly available, and give reports such as how your company's product or how, differs in its usage across countries, or what city you may be able to hire developers in. Thank you.
Thanks, David. As we're at the end of the session, I'll allow one more question.
I have a question. Who tags the questions on Stack Overflow, and how is that moderated?
The asker tags the questions originally, so and it's required to put at least one tag on the question. If you say forget, or you ask around, if you put a bad tag, usually what will happen is users with a certain amount of reputation can edit your question for you and correct the tags that are on it.
I'm sure David is also open for more questions, but I'd like to close the session now. Thank you to David and all the other speakers, and thanks for coming to the session.